Okay, this is another video in the series, What's in the Bleakin Beaker? And this time, it's another hydrolysis, but I'm starting you off with the salt ammonium chloride. And so when that dissociates in water, you form the cation ammonium ion and chloride. And you know that chloride comes from hydrochloric acid, so that's a strong acid, so chloride just spectates. Ammonium ion is the conjugate acid of a weak base called ammonia. So because ammonia is a weak base, its conjugate acid will hydrolyze. It will react with water. And so you write your equilibrium starting with the ammonium ion, which we said was the conjugate acid of ammonia, and we let it react with water. Because this is the acid, water's going to act as a base, so it is going to accept the proton, and you end up with ammonia plus the hydronium ion. So this is called acid hydrolysis because it's the cation of the salt that reacts with water. Again, I need to give you the concentration of the ammonium chloride, and I'm going to say it is 0.25 molar. And that means that the ammonium ion is also 0.25 molar, as well as the chloride, but it's only the ammonium ion I'm interested in. So generating our rice table, we start with 0.25 molar ammonium ion. Ignore water. We don't have any ammonia or hydronium ion initially. Some of that reacts with water, produces ammonia, produces hydronium ion, so that at equilibrium we end up with 1/4 molar minus X, X, and X. Going to our K expression, remember, it is this that we have to watch out for. Which K do I plug in? So this is not a base. What is this? A conjugate acid of a weak base. So this time I want the hydrolysis constant to be a Ka. And if you remember from the previous video on hydrolysis, I can find the Ka by ratioing the Kw to the K for the base. So K for ammonia for NH3 is 1.8 times 10 to the negative 5. Therefore, K for its conjugate acid ammonium ion is going to be 1 times 10 to the minus 14 divided by 1.8 times 10 to the negative 5. And we find then that the Ka for this acid, ammonium ion, is 5.6. I'm pretty sure. Let me just double check myself. Yeah, 5.6 times 10 to the minus 10. Okay, so that's the value I plug in here, is 5.6 times 10 to the negative 10 equals X squared over 0.25 minus X. Remember what we said, hydrolysis constants are very small, and so we know that X is very small compared to the initial concentration of this ion in solution. So we find X, go back and relate it. What is X defined to be? Hydronium ion concentration. And solving for that, we take the square root of 5.6 times 10 to the negative 10 times 0.25. And we get 1.2 times 10 to the negative 5. That's a concentration, so put its unit on molarity. So if I take 0.25 and subtract 1.2 times 10 to the negative 5, to 2 sig figs, I'm going to end up with 0.25. So now you can see why we didn't have to worry about subtracting X from the initial concentration. X is very small compared to the initial. So if the problem asks you what is the hydronium ion concentration, you're done. If it asks you for the pH, then the pH is simply the negative logarithm of the hydronium ion concentration. And so we can do that. Concentration of hydronium ion, pH is the negative log of 1.2 times 10 to the negative 5, I believe it was. pH is unitless, so negative log of 1.2 times 10 to the negative 5 is 4.92. Now remember, pH and POH scales only count digits to the right of the decimal. The 4 is not counted in your sig figs. You have 2 sig figs here, I have 2 now. So that would be the pH if the question asked you for the pH. If the question asked you for the concentration of hydroxide ion, so if it asked you to find concentration of this, well, don't forget the product of hydronium ion concentration and hydroxide ion. Their product will always equal, in an aqueous solution that is, Kw for water. So if you know one of them, you can always find the other one. So take 1.0 times 10 to the negative 14 and divide it by the one you know, which is hydronium ion, 1.2 times 10 to the negative 5. And so the hydroxide ion concentration is 1 times 10 to the negative 14 divided by 1.2 times 10 to the negative 5. And you end up with 8.3 times 10 to the negative 10, and that's a concentration. Put molarity on it. So no matter where I need to go, always reread the question and figure out what they want. This is what you're always going to go get. In equilibrium, you're always going to find the amount that's associated. But where you go from there, reread the question to find what it's asking for. Hydronium ion to hydroxide is an easy calculation. Hydronium to pH is also easy. And that's acid hydrolysis.